Well, hello, it's me again, talking to my favorite Pre-Cal 1 class. We're going to do Unit 5B, Lesson 2. This time we're going to talk about the cosecant and secant functions. Remember, you do have a note-taking guide that goes along with this that has a lot of details on it that you're not going to see in this video written down, okay? So you want to refer to that. So cosecant. Same standard form, except this part right here, the trig function, is different. Remember that it is the reciprocal of sine. So therefore, to have a lot of the same characteristics as sine, except it will have no amplitude, no y-intercept, because it has asymptotes. Okay, if you were to graph that in your calculator, cosecant x, it would end up looking like this, where you have asymptotes there, and then here, and then you got an asymptote there. It looks a little funny, okay? So this is kind of what it looks like here, and as you can see here, this is why you don't have an amplitude, because these little wings right here, these little branches of the graph, they keep going up forever, so we don't have a maximum. These keep going down forever, so we don't have a minimum either. So you remember when I told you in the first video that your amplitude is your max minus your min divided by 2. We don't have a max and min, so therefore you're not going to have an amplitude, okay? So let's see what the graph looks like, okay? Remember, refer to your note-taking guide. Okay, a lot of things are going to be the same, but as you can tell, this is going to be different. Oh, I wanted to get to the show you about the reciprocal of sine. This is kind of neat right here, that you can see it's actually the reciprocal of sine, because if you were to flip sine, there we go. That's what I wanted to show you. Say this is your x-axis right here. Yeah. Okay. So if you wanted to, if you were to cut sine in half and flip it, then you would get cosecant. So they share a lot of the same points right here. Okay. And all of that stuff. And so you'll see that as we move along here. They share all those critical numbers right there. That's why it's a lot alike sine until you actually graph it. Okay. All right, so let's see what we've got going on here. Amplitude is 1. Okay. Because remember, you can write this as y equals 1 cosecant x. Sorry, got too fast. Cosecant of 1x minus 0 plus 0. So A is 1, and amplitude is the absolute value of A, and then period is 2 pi divided by the absolute value of B. So here B is 1, so that's just going to be 2 pi. Remember what you've practiced so far. Your critical, if your period is 2 pi, your critical points are always the quadrant angles. So that'll save you a little bit of time right there if you remember that. Okay, and of course your parent function, there will be no shifts, no flips. Okay, all right, so let's get that graphed and see what it looks like. Okay, so y, x right here. You got a lot of rules to remember for this, so you don't need to be slack on this stuff. You need to make sure that you're studying your rules and keeping them all straight and all that stuff, okay? Remember, your amplitude and its opposite goes on the y-axis. There we go, okay? So, here we go. Your remember I said you don't have a y-intercept. And that is because your y-axis is actually going to be an asymptote. Okay? And I'm going to dot that line since it's an asymptote. Okay, I like to dot all the asymptotes. Okay, so here's my y-axis. I'm sorry about that, y'all. There we go. Okay. There we go. Alright. That's because when x is 0 right here, okay, if you were to put 0 in the place of x here, then the cosecant of 0 is undefined. And that's why we have an asymptote there. Now, the cosecant of pi over 2 is 1. The cosecant of pi is also undefined. So we're going to put an asymptote right there. The cosecant of 3 pi over 2 is negative 1, so we're going to put a point right here. And then the cosecant of 2 pi is, you guessed it, undefined. Okay? And so what we're going to do here to complete our graph is we're going to follow this pattern over here to get another period, because what we've graphed here is just one period. So we have an asymptote here, and then we have a point down here, an asymptote, a point up here, asymptote. So now we're going to go down to here, just following that pattern along. And then asymptote, okay, and then we were down here, asymptote, so we're going to go back up right here, and then asymptote, okay, and then you're just going to follow those asymptotes along to get your little branches. And that is what your parent function for cosecant looks like. Now, of course, if a is negative, then this is going to flip, right? And because you follow the same rules as sine, if a is negative, you flip. If b were negative, you would flip. If they're both negative, there are no flips, it flip-flops. Okay? So, with cosecant, or negative cosecant, all of this is the same except you're going to flip over the x-axis. So this point right here comes to here. This point would flip up here. And see, the asymptotes are going to stay in the same place, because if you flip this line, it's going to still be that line. Okay, so the green, that is your y equals negative cosecant x. That's what it looks like if you have a flip. And then what's in the pink, that is your y equals cosecant x. Okay, and again, I'm going to do the same thing that I've been doing. I will always graph the parent function with its flips and stretches because of whatever the amplitude is, or shrinks, but I will use an X to mark any points that I'm going to move due to a shift, okay, which I think is coming up in the next one. Alright, so if we look at this one, yep, here we are. Okay, let's analyze what's going on here. I have a amplitude of 2. The period is going to be 2 pi divided by the absolute value of b. So that's just going to be pi. My first critical number will be 0, and then the next one will be the period divided by 4. The next one will be this number times 2. Which will be pi over 2. And then this number times 3, which is 3 pi over 4. And then this number times 4, which should bring you back to the period, and it does. Okay, as far as shifts are concerned, I don't have any horizontal shifts because there's nothing being added or subtracted on the inside of parentheses. But I do have something being added on the outside, so that gives me a shift upward of 1. And then flips, well, A is positive and B is negative. So remember, cosine follows the rules of sine when it comes to flips. So that means that we are definitely going to have a flip here. Okay? So let's set, whoa, I don't want a dotted line and I don't want it pink either. Let's fix that. There we go. Okay, so we're going to set this up. Our amplitude is 2, so I need to leave room for that and put their opposites. But I do have a shift up, so I know I'm going to have to add another unit up here so I can make room for my graph, okay? Alright, so if you go back to your parent function for cosecant when you have a flip, okay? You will always have a vertical asymptote on the y-axis for cosecant unless there's a horizontal shift, and then that may change. It may or may not, okay? So we're going to look at the fact that we've got a vertical asymptote on the y-axis, and with flips we would have to have an asymptote here and then go down on the next critical point, and then asymptote, and then go up on the next one, and then asymptote. So that's the pattern I'm going to follow for this graph over here. Okay, so I know that this right here is an asymptote. So usually instead of using an X, I just use short little vertical segments to show that that's an asymptote. And then from here, remember, because I have a flip, I'm going to go down. My amplitude is 2, so I have to go as far down as -2. So I have an asymptote here on this critical point. On this one, I have a point at -2 for the parent function. Remember, I'm not doing shifts yet. The next one is an asymptote. The next critical point, I'm going to go up to my amplitude of 2. And then the next one is an asymptote. Now I'm going to follow this pattern right on around to the other side to get the other period, because this is one complete period here. So I have asymptote, up, asymptote, down, asymptote, up, asymptote, down, and then asymptote. Okay? So, what I'm going to do now is to take care of my shifts. Alright, everything's going to be moved up 1. Well, in asymptote, well, that's a vertical line. And I can't just move a vertical line up and down. It's going to stay on that. So really the only thing I'm shifting are these points right here that are actually defined as an X and a Y. Okay? So this point right here is going to go up to that -1. This one's going to come up to this 3. This one's going to come up to -1, and this one's going to come up to 3. Okay? And I am going to get my asymptotes in there. I'm going to dot my y-axis. And usually what I tell students with secant and cosecant, because they both have asymptotes, is if you're not sure yet if you're going to have an asymptote on the y-axis when you go to draw your coordinate plane, just go ahead and make it dotted, because you can always fill it in and make it solid, and that'll save your eraser a little bit. Okay? Alright, so I have an asymptote here and an asymptote here. I got that asymptote, but we can still make it pink and pretty. Got that one in here. Okay. And then all your points at the top, you want those to open up. And all your points at the bottom, you want those to open down. And just follow along those asymptotes. Okay, and try not to hit them. I hit that one, but it's okay. Okay, and that's what that graph looks like. Okay, let's do another one, then we'll move on over to Secant. Okay, this one, follow along with your note-taking guide. I did put you a note in there to remind you that on this one we need to factor out B. And that is because B is not 1 and C is not 0. So I'm going to go ahead and factor out that 2 right there. Remember, factoring out a 2 means you're dividing both of these by 2. So that leaves me with x here and then pi over 2 here. Okay, so with this one, A is 1/2, B is still 2, C this time is pi over 2, and D is -1. Okay, so my amplitude will be 1/2, the period will be 2 pi divided by 2, which is pi. So my first critical point is 0. After that, I take the period and divide it by 4. And to get the next one, next critical point, I multiply my pi over 4 by 2. And then I'll multiply pi over 4 by 3. And then I'll multiply pi over 4 by 4. Now, my shifts, I have a horizontal shift here to the right, pi over 2. And a vertical shift down 1. Flips, well, A and B are both positive this time, so there are none. No flips, okay? So let's graph this. Let's see what we got here. You know, graphing these are not bad. It's a little tedious, can get a little boring, but it is something you so need to know for when you move on to either IB Math 1 or AP Calculus, whatever it is you plan to take, or you can take both. Who knows? I really should be singing to y'all. I don't know what to sing though. Wake up, little Susie, wake up, just in case you're asleep. That's an oldie song. Wake up, little Susie, wake up. Wake up, PreCal class, wake up. Okay, let's see what we got going on here. Enough of that silly nonsense stuff. Okay. Let me see. So, parent function for cosecant, if there are no flips, we would have an asymptote on the y-axis, and then we would go up to the amplitude, keeping in mind that the amplitude is 1/2. Then the next critical number would be an asymptote. The next one will go down just 1/2 and put a point, and then the next one is an asymptote. I'm going to follow that right on around. Okay. Oh, wow. Okay. All right. So now I'm going to do my shifts. Now I have a shift to the right pi over 2 and then down 1. So pi over 2, remember you need to measure how far that is. Well, from the origin to here is pi over 2. So it's 2 of these units is pi over 2. So everything's going to go to the right 2 of these units on the x-axis and then down 1. So I'm going to start right here. I'm going to move this asymptote to the right here. Here's that asymptote. Okay. And I didn't take it down because you can't take a line up or down. It's just going to stay on that line. Okay. Now this point to the right 2 of these units and then down. Don't forget to move this asymptote right here. Actually, all of our asymptotes, if they move to the right, they're actually going to stay where they are, aren't they? Like if this asymptote goes 2, isn't it going to be right here? Okay, and then when this one goes to the right 2, it's going to be right here. This is not as pretty as it could be. And then when this one moves to the right 2, it's going to be there. Okay, and if you don't want to extend this side, this x-axis right here, like I showed you in the sine and cosine video, you could just follow your pattern back around to the left, and you see all these asymptotes, they are pi over 2 units apart, aren't they? So you know you're going to have one right here too. Okay. Now that point we already moved. We went to the right 2 and down 1. We need to move this one to the right 2 and then, oh, I only went down 1/2 right there. I need to fix that because I was supposed to go down 1. Bear with me here and let me make this as pretty as I can again. Okay, let's try that again. So this point, it goes to the right 2 and down 1. So this point's actually going to move to that point. Do y'all see what's happening here? Don't forget to move that point. That point goes to the right and then down 1. This one goes to the right and then down 1. Let's move that one to the right and then down. So we do need to extend that, don't we, right there. Oh, Lordy mercy. There we go. That's 1 pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, 5 pi over 4 is where that one is, okay? So, let's see what we can do about filling in over here. Here, these bottom points, they're at negative 1.5. And then this top row of points are at negative 1/2. So this has a point, 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 point. I need a point right here, don't I? And that'll fill in, that'll complete my 2 cycles there. Okay. Now, remember, bottom row, their branches go down. Top row, theirs goes up. Yeah, I can fill that in. Okay. Alright, so it ain't pretty, but it's right. Okay. Alright. Let's move on here to secant. Secant is the reciprocal of cosine. So it has the same characteristics of cosine, except it has no amplitude. Okay. And it also has asymptote. So it looks a lot like cosecant. Okay, let's see how this is going to turn out. Well, hold on. I have a problem in here somewhere. There it is. Okay, so y is equal to 1 times secant of 1x minus 0 plus 0. This is your parent function. Amplitude, again, whoa, I think I made a big boo-boo back here a while ago. Hold on. I did. I made it every single time, and we need to fix it. Okay? Yeah, because I told you we have no amplitude, and we don't. Okay? This should be none right here. Every single time you should write none. I think what happened, 2 reasons. I'm doing these videos back to back. And I just did sine and cosine. Alright. Second reason is, even though there's no amplitude, you notice that we still use A on our y-axis. Okay? So, yeah, we need to write none right here where it says amplitude. Oh my goodness. Well, I'm glad I could model for you what not to do. Okay, so let's come over here. Let's try this again. Amplitude, none. The A is 1. And we will be putting it on the y-axis just like we did for cosecant. I'm so sorry about that. Period. 2 pi divided by the absolute value of b. b is 1, so that's just 2 pi. I think we know our critical numbers when our period is 2 pi. These critical numbers are our quadrant angles. Yes, I like to say it every time because you really can't hear it too often. There's nothing wrong with repetition sometimes. Shifts, C and D are 0, so none. Flips, A and B are both positive, so none. Okay? Now let's see what this is going to look like. Okay. Remember, you're going to follow the same rules for cosine, because cosine and secant are inverses or reciprocals of each other. I need a trig song. If it weren't for trig, I don't know where I'd be. I wouldn't be on the ocean with a wave. Get it? Trig, wave, sine wave, cosine wave. Okay. Okay. Amplitude is none, but again, we're going to plot A up here. Okay. And its opposite. Alright. Now, let's see where stuff is going to happen. Start right here on your first critical point, x equals 0. And just ask yourself now, what is the secant of 0? Yes! It is 0! The secant of 0 is 0. No, it's not either. The secant of 0 is 1. Let's try this again. Oh my goodness. Miss Fletcher. Okay. So the secant of 0 is 1. Okay. Secant of pi over 2, undefined. So here come our little asymptotes. See, wherever your trig function is undefined, you're going to have asymptotes. Preferably straight ones. Secant of pi is -1. Secant of 3 pi over 2 is undefined. Now see this pattern going on? Secant of 2 pi is 1. Now that's one complete period right there. Let's follow this around to the other side and complete it. So I have up on the 1, asymptote. Down on the -1, asymptote. Up on the 1, asymptote. And then down on the -1, asymptote. So every other critical point is an asymptote. What I just say? Every other critical point is an asymptote. And now we're back up right here. Okay? And technically you don't have to do the other side here because it puts you past that -2 pi. But I don't care if you do. Remember, top row, everything opens up, right? And bottom row, everything opens down. Okay? And again, you can just do that half right there if you want to. A lot of times you see that parent function looking like that, where you don't have the other side right there because it goes past 2 pi or it goes past -2 pi on this side. Okay, but that's what your parent function technically looks like. So we'll just go with that for right now. Okay, now, of course, if you flip it, okay, if you flip a line, it's still going to be on the line. So if you, when I flip y equals secant x, then this point flips down here, this point flips up here, this point flips down there, this point flips up there, this point flips down there, and everything on the bottom opens at the bottom. All the points at the top open at the top. Y'all please learn your rules and don't make this difficult on anybody, okay? Alright, 2 more. Okay, -2 secant x minus 1. Okay, amplitude, none. But we will be plotting A and its opposite on our y-axis, okay? Period, well, B is an understood 1 right here. So period is 2 pi again. That makes your critical points easy. Study hard and pick up on patterns, okay? You have a -1 here. It is not inside parentheses. It's outside, so that means it's a vertical shift, and we're going to go down 1. And secant follows the same rules as cosine. Here, A is negative, so that means, yes, we have a flip. Refer to your rules, okay? Gotta know those rules. Study them, learn them. Best time to do that is now. Okay? Alright, so I'm going to put these up here. And, you know, I always get the question, do I have to write these angles on the x-axis? I'm going to go ahead and address that now. The answer is yes, you do. Every single time. Every time. I don't want to ever guess what you're thinking. I want you to write down exactly what you're thinking. about math. About math. I don't know what you think about anything else. Okay. Let me see. A is a -2, and I need its opposite. And we're going to be going down 1, so let me put a -3 down here. Okay, here we go. I'm going to put everything up here except for my shifts, okay? So I need to be thinking about what's going on. This is my base graph for secant, and it has a flip. So if you come back over here and look at what that looked like when you had a flip for secant, okay? Your y-intercept is down here at 0, -a, all right? So we're going to start at the bottom at the y-intercept, and then the next point will be, next critical number will be an asymptote, and then we'll go up, okay? Just like cosine. Oh, I meant to show you this. Look at the pink graph and see how the pink graph right here relates to cosine. Do you see how if you were to draw the cosine function, that secant function is actually your cosine function that was cut in half by the x-axis and then kind of flipped upside down, okay? So this is your cosine function right here. So you can kind of see why we say it's the reciprocal or the inverse of cosine, okay? All right, so getting back to what we're going to do over here, all right? We're going to start down here because, refer to your handout, okay? That hopefully you wrote this on, but we're going to start down here at the bottom because this is flipped, okay? So I'm going to start with a point here. And then this will be an asymptote. In the next critical number, there'll be a point. Asymptote, and the next one will be a point. Now again, you know, if you don't like my method of, I meant to use x's, y'all. X, X, X. I just like to use x's, okay? If you don't like my method of using the little x's and the tick marks, you know, you can come up with your own. It's fine. You know, just come up with something that works in which you're going to get it right, okay? And ask questions, please. Please ask questions if you have them. Okay, so we have a shift that's going down 1. So all these points are just going to go down 1. The asymptotes are lines, so they don't go up and down, they don't flip. They don't really move unless you have a horizontal shift, okay? And then this one goes down 1. And I hope I'm making this easy for y'all. Well, I'm not trying to make it easy necessarily as I am to just simplify the whole concept of how you graph these without a calculator. Okay, this one has to come down 1. And there's the asymptote. And this one comes down 1. Okay? Everything at the top flips up. Everything at the bottom flips down. And there you have it, boys and girls. We are done with that one, and we're on the last problem. Yes! Okay. Now what you notice about this one is B is not 1, C is not 0, so we're going to factor. Factoring out that 2, now you're dividing both of these by 2 when you do that, okay? So that just leaves me with an x here minus pi over 2 divided by 2 is the same thing as pi over 2 times 1/2. Get hooked on fractions. So pi over 4. And then plus 1. Okay? So we're going to use this equation right here, in which this is my A, that's my B, this is now C, and this is D. So amplitude is still none, but we will be plotting -2 and 2 on the y-axis. Period is 2 pi divided by the absolute value of b. b is 2 in this case, so that's going to be pi. My first critical point is 0, and then after that I take the period and divide by 4, and then I multiply this by 2, and then I multiply this by 3, and then I multiply this by 4. Shifts, we've got 2 of them. Looks like we're going to go to the right pi over 4. Oh my goodness. I don't know how that happens sometimes. Well, it's happening again. There we go. And then we're going to go up 1. And do we have a flip? Yes, we do. Because A is negative. My dog's snoring. Yeah, she gets bored with trig too. It's not boring, it's just a little tedious, and you really, you know, you do have to think about this stuff. Okay, so pi over 4, pi over 2, 3 pi over 4, pi. Do their opposites over here. We're going to plot A. A is -2. Put their opposites, and we are going to be shifting up 1. So let's put a 3 up there too, okay? Alright, so let's see. Okay, we have a flip this time, don't we? Okay. Oh, we had a flip last time too. We shouldn't have put a flip in here. Oh well. Okay. Remember what I said about a flip? Okay, with secant, you're going to start at the bottom where your y-intercept is, and then the next critical number is an asymptote, and then you're going to go up, asymptote down. Follow that pattern. Okay, so we're going to start right here, not with a point, Miss Letchworth. Come on, girl. There we go. So that's a point, asymptote, point, asymptote, point. Follow the pattern on around to the other side. Okay, now we're going to shift everything pi over 4 to the right and then up 1. Measure pi over 4. Pi over 4 is just one little unit right here. That's how much it is. Okay, that's how much you're moving. So I'm start right here with this point. I'm going to move it just one little unit to the right and then up 1. So 1, 1. Takes it right there. This asymptote gets moved to here. This point, 1, 1. This asymptote gets moved to here. This point, right 1, up 1. This asymptote, it moves to here. This point, right 1, up 1. This asymptote, it gets moved to here. This point, right 1, up 1, right there. Okay, and we can extend that graph. One pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, 5 pi over 4. Got the hang of that yet? Of course you do. Okay. Alright, let me put my asymptotes in there. Okay, so I have an asymptote. I wanted it to be pink. There we go. So I have an asymptote here. I have an asymptote here. I have an asymptote there. I have one there. If I follow that pattern, I know I'm going to have one there as well. Okay? And so now all my points on the bottom will open at the bottom. My branches rather, and all my branches at the top will open at the top. And that, boys and girls, is how you graph cosecant and secant. And we're done with that one.